Hi. Yes, I'm a bit obsessed with Dynamic Signal Analysers, DSAs. You've seen my previous videos on the HP35670A Dynamic Signal Analyser. Well, I've got another puppy. This is the HP35670A DSA, and it's sort of like the big brother to that previous model, and this is still actually a current model unit. It goes for about $22,000 US, brand new, and yes, it's not working, or supposedly. That's what the guy who sold it to me says anyway. And apparently he spent, says there was a fault with the power supply, and he spent $1,600. Man, he got shafted to fix the power supply. And apparently, well, that was fixed, and it still didn't fix the problem. So hopefully we get a repair video out of it. Now, this one is a 16-bit Dynamic Signal Analyzer. It's got a 90 dB dynamic range, optional swept sine mode. It gives 130 dB dynamic range. I don't think it has the swept sine option. I can't see any options on the back anyway. And it's seen better days, I think. But anyway, yeah, fingers crossed, repair video, and hopefully I can fix it. Otherwise, it's going to be an expensive paperweight. And here it is, and it's a relatively modern looking unit, at least compared to the other one anyway. Yes, still has a 3.5-inch floppy on here, and dual channel, of course, pretty much exactly exactly the same functionality as the previous one we've looked at, except it does have an external mic thing here, which you can get like a separate module to hook up microphones and accelerometers and other things like that. But basically dual channel plus the source and all the system stuff we saw before. It's even got a basic key. Brilliant. Marker works all. If you use the other one, this one works just as well. But look, you can see the screen there is just something's happened to it, and it's likely not the screen itself. It's just the plastic or the screen filtered cover on that, the screen cover. So yeah, I don't know what. It almost looks like it's some sort of. It's like peeled off, or some sort of laminate is sort of peeled off that or something. And people have been scratching the screen. I'm not sure if you can get that, but look, people have sort of used a pen and sort of scratched things on there. But anyway, hopefully the CRT is still good, so we'll power this sucker up and see what happens. It is significantly smaller and more compact than the previous model, and it also has a DC option as well. There's a DC option, there's a DC jack on the back, and a big switch to select between 240 AC or optional DC, because these ones were designed for field use, hence the rubber bumpers around here and stuff like that. So not just for the lab, but to go out on site and do acoustic and vibration measurements out on site. You'd lug this thing, but it weighs a ton. I don't know, it's about 20 plus kilos or something. Weighs as much as the old one. And that looks like a cow date of 2003 there. Just make it out, but anyway, she is a fail. And it does come with a really old school protective cover on it. Makes it look really ancient. I mean, this is obviously one of the first models. Probably the new one doesn't have an ancient looking thing like that, and it would be Agilent branded as well. The interesting part about that is that you can lift it up and you can store stuff in there. Really handy. It's got an Allen key. I'm not sure what. Maybe we need that to get into the thing. I don't know, but it smells. It smells weird. It smells like WD-40. I'm not sure. It's some sort of lubricant oil or something. Weird. And there's the big clunking source select switch on the back, the Akadaka switch, as I like to call it. But it's got a nice big protective guard around that. Really like it. And there's the DC jack input. It looks like some sort of LEMO connector, a 2-pin LEMO. Offhand, I'm not exactly sure of the exact type there, and I'm not sure what DC voltage. Haven't read the manual, but presumably like 12 volts or something like that. And on the back, all the regular stuff: serial, parallel, external monitor, which is really quite nice if the internal monitor doesn't work. Beauty. That could be a lifesaver. But yeah, there's no other options or anything like that. The seals have been broken because this thing's been opened. And yeah, there is no option written on there, so I was hoping to get the swept sign option, but oh well, you can't have everything, and a crusty looking keyboard port. And just to prove that he did have the power supply fixed, he thoughtfully included the original invoice for that. And check it out, $1,685 for repairing this power supply. Unbelievable. And what do you know, the Allen key fits. Beauty. This looks like it's going to be too easy. It's slid off. Here we go. I believe I can get the service manual for this thing. Haven't looked yet, but this should just slide off. And whoa, we're in like Flynn. Can see some gunk though. Check this out. Look at this. There you go, look at that. Ugh, that's like, I don't know. What it looks like is I think something's been spilled through the back of this vent here. And you can see the spill marks coming across there, and it's run down into part of the power supply here and also across the board. So that certainly needs to be cleaned up, and that's certainly not factory original. You can see a fair bit of corrosion on this metalwork here holding the power supply in. I mean, all the aluminium's fine of course, but this looks like this steel bracket here has you know, just sort of started to rust away. It's, you know, probably been used in some sort of you know, tropical environment or something like that, and yeah, it doesn't look great, but shouldn't affect the performance. Now, if you compare this with the previous video, teardown video of the other DSA, which I'll link in down below, you can see that they've sort of copied the same sort of style. They've got the plug-in cards here with the little levers to pull them out, the bracket to hold it in here, and these cards all just slide out. It's rather, you know, it's a rather nice design. And then they've got the little coaxes connecting the boards exactly like they did in the other one. And on the top side, coming from the power supply here, they've got the ribbon cable coming over, which no, it probably doesn't take the data like the other power supply. It takes all of the power over instead of, you know, discrete wiring. It's just a neater way to do it, and they've really put you know, quite a bit of thought into this. I really like it, and lots of socketed PLCC parts up here by the looks of it. Lots of test points that we can get to. Unfortunately, they're oh yeah, ground, TP, yeah, 5 volts. Yeah, well, we should be able to measure a few things, but that's very thoughtful. Look, nice little post in there you can get your oscilloscope probes onto and probe this thing while it's all still in the chassis, which is fantastic. And of course, one of the reasons they're able to shrink the size of this thing down compared to the old one, even though the boards are still huge, full size, doesn't use a CRT. Of course, this one is an LCD based unit, and we can see the chipsets in there for the LCD display down in there. But that makes it really nice to troubleshoot, although the weight of this thing, you know, still all that shielding and metal, and, you know, like really they've gone to town on the design of this thing, really belt and braces, gilding the lily stuff in terms of all the shielding and everything else. So that's why the damn thing weighs a ton. And on the back here we have some vent holes, a cable routing diagram, rather neat, and it looks like the front panel board you can just access directly. I mean, there's the B and C's right there, right angle, presumably the right angle B and C's. Yep, it mates up directly. You'll notice how we've got an unpopulated B and C there. That's actually for the 4-channel version of this, and the 4-channel version exactly the same as this, but they they use the source one here, which is the output on the 2-channel version. That's actually an input channel on the other, so I guess they just changed the cable routing, and that's why they've given us a 2-channel cable routing diagram for the 4-channel board. Actually, that's probably what this unused slot here is, the extra channel board. So they install the extra boards, and then you'd have a particular routing scheme for the 4-channel version, and they use that the source output comes from the back panel. There it is, source going to the rear panel, and on this 2-channel one they've also got the source going to the front as well. And once again, check out the RFI fingers there that that connect the chassis down to the case. Just keep all the RFI crap in or out, depending on which way you want to look at it. Generally, for this sort of high performance precision instrument, at low level precision instrument, they're looking to keep stuff out. And we have ourselves some PCB mount DIN connectors down in there. The other ones look like our standard DIN 41612. First thing, of course, I am going to power it up and just confirm that it is dead. So fan goes, so the power supply is going. We've got our green power light there. But we're getting zippity doodah on the screen by the looks of it. Bugger all, but yeah, probably worth measuring some test points now, although I think first step is probably download the service manual. And yep, 5-volt rails okay, at least on the main processor board, so that's a good start. All of the other test points down here are unlabeled, so you can go around and it's just got TP240, so you need the manual for that, but you can go around and sort of probe those, and if you get voltages like plus minus 12 volts or plus minus 15 volts, for example, then you know that they're power supply voltages. There we go, 5 volts. The other test points on here are all various test signals from the processor. But one thing that tells me that this thing isn't booting or is having sampling issues or something like that, is that there's no beeping at all. You'd expect to sort of hear the odd beep or two. I don't know, I haven't used one of these things for like 10 years, so I can't exactly remember how often it beat. But the other thing is there are half channel lights here for half the voltage in the overrange lights. Usually I'd expect those to go out, and of course run the self-test. You'd hear the relays as we did in the previous one, self-testing and all that sort of stuff. After boot up, can't hear anything like that. All I can hear is the whir of the fan, and that's it. So it looks like that the processor is not starting up, most likely, although we've got 5 volts on the main board. Holy crap, I just downloaded the service manual, and it comes with no less than a 70-page troubleshooting guide inside the service manual. Unbelievable. That's 70 pages, step by step, of how to troubleshoot this sucker. Oh man, that takes all the fun out of it, really. Now we're getting our green light on the power supply over here, and I'm not sure how extensively it tests its own, actually tests itself, but the power supply is basically working. We've measured the 5 volts, so next thing to do is measure the 10 megahertz main processor clock signal here, and what do we get? Look at that, complete fail, folks. Fantastic, I love it. This is the kind of failure that you want. A direct no 10 megahertz processor clock. Well, that just stop right there. Go track down that problem, fix it up. Brilliant. So that points towards our processor board down here, and I'm not sure about the top board. I have probed the gunk there, and it's not conductive, so yeah, not a big deal. Oh, look, we've got some Actel parts. This is rather interesting. Let's check this out. Now this isn't the main CPU board, that's actually on the top of the unit that's got the gunk on it. This is the digital processing board. It's got a lot of Actel 84-pin PLCC parts here. These are all socketed, very nice. Now we're not getting the 10 megahertz on that pin there. Now whether or not that's generated on the board here, is that a no? I can't see an oscillator. We've got a relay over there, but most likely the reference clock, the system clock for this digital board, is generated on the main processor board. So we could be following a red herring here by, thinking that there's something wrong with this board. Although, a classic failure mode may be that one of these PLCCs has become unseated, or you've got a dodgy contact in there. It's, as a basic troubleshooting procedure, it's worth also, after you've done the basic checks, of course, to narrow things down. But if you're scratching your head a bit, take these chips out, use a proper PLCC extractor, or be very careful with a small screwdriver, and just reseat them. Or even if you don't take them out, at least give them a good push. Make sure your board is flat against the bench, so you don't stress the board and crack any solder joints or anything like that. But just reseating these sockets can solve a bit of problem. It looks like we might have some ROMs under there directly soldered into the board, which is a bit surprising. So as usual, these all have, the HP part numbers on them. So the Actel devices are probably, PLDs or small FPGAs or something like that. I'm not sure when this was designed, back in the early 90s, I think, what Actel were doing in that area. It could even be a custom, gate array part or something like that. We've got some memory happening around here, but yeah, interestingly, we've got these sockets down here which have no load written on them into the silk screen, if you can see that. So, at the PCB design stage, the PCB layout stage, the layout designers go, well, we know we're not going to load that part, so I'm going to put no load directly on the silk screen. So maybe they're only for development or test debugging purposes or something like that. So anyway, just wanted to have a look at that board. I'm not going to start troubleshooting this board because I'm going to go to the main processor board on the top because I think that's where the issue is. And of course, we have some visible signs of gunkery happening around here. So it's worth unscrewing. Unfortunately, we have to unscrew this bastard and flip it over to get to the top side. But because it's in there with a nice... oh no, that's the motherboard connector. So really... we can't access that, and no test points are labelled on the bottom, unfortunately, which is a real bummer. But anyway, worth taking that out, flipping it over, and giving it the good old visual inspection. Now, of course, given that this has a known power supply failure mode, then really we have to also consider the possibility of that the power supply, has failed, obviously, but it's also could have taken out something on the board. And well, digital stuff is not hugely tolerant of over voltage like that. All the 5 volt, I think it's like, there's no 3.3 volt stuff on this. I think it's all like old school 5 volt TTL level stuff, as we saw in the previous version. But yeah, they don't tolerate huge over voltages. So that could be a real pain in the ass if that's happened and taken out multiple devices. So yeah, in that case, it might be beyond economical repair kind of thing. It depends on how many hours you want to spend. I've troubleshooted digital boards that have had, a dozen chips being taken out and failed, and it's just not fun. It takes forever. So we've got some motherboard connectors. These are DIN connectors down here. It looks like I'm going to have to lever that out. Woohoo! Check this out. Modern as. Look at these quad flat packs. Virtually all surface mount construction on the main board here, the main processor board. Unbelievable. We've got a memory board down here which connects via this DIN 41612 connector down onto the main memory board, and yeah, you can get memory expansion for it. There we go. Looks like we've got some standard memory expansion sockets. We can just whack those in. Made in the USA stickers all over this thing, by the way. USA, USA. There's an NSL lithium battery backup, so worth measuring that, but of course that's not going to stop this thing booting up at all. But yeah, we can expand the memory. That's great. Unfortunately, we can't probe this. We've got some, without it being plugged into the top, and we've got some nice status LEDs over here, unmarked, so we'll have to look at the manual for that. We've got some little secret squirrel switches on the back panel there, and anyway, there's our crystal. That, because we're getting no clock, we have to look at that. There's something interesting. Let's take a look at that. Check out the old school trimmer cap in there to adjust our main reference oscillator. Oh, thing of beauty and a joy forever. And there's our main processor for all you Motorola fans, MC68030. And over here they've got a Motorola 56000 series DSP. They've changed from the Texas Instruments 320 DSP they had in the previous model. And that sucker was end-of-lifed back in 2002. But, date code, there we go, 9506. So, 1995 vintage unit we've got here. But anyway, I don't see any signs of trauma on there. There's no blowouts in the chips or anything like that. So, I wouldn't rule it out. But, there hasn't been, a drastic over voltage on the power supply. So I might whack that back in and see if we can measure our main oscillator there. But what I'm going to do first, of course, is clean off the gunk. And that battery's still good too, although for long term you'd probably replace it, but for the purposes of today's repair I'm not going to. Well, it turns out there is a labelled test point on here in the copper, 20 megahertz, and we probed that and we're getting naff. Look at that. I mean, that's 1 volt per division, and there's just, you know, there's something there at you know, what, 150, 200 millivolts or something like that, but that's just ground. Well, you know, it's picking up some crap, I don't know, but there's definitely no reference oscillator. Once again, fantastic result. We've got something to work on. Uh-oh. All of a sudden, our power supply green LED has gone out and we're getting absolutely nothing anymore. So, I don't think I touched anything. And this is all rather nice. It popped off the back cover here, just folds off, and we've got ourselves a separate board on here for the source, output, and stuff like that, and the GPIB and all sorts of other things, some flat flex there, connecting those in. So to get that panel out, you don't have to undo all the annoying jack screws and BNCs and things like that. So that's really nice system design. You can see the back plane that they've got in there. So this board, top board here, plugs into a right angle one on that back plane, and then the slotting cards plug into there. Got a nice right angle ribbon cable here. Ah, beautiful. And there's inside our switch mode power supply. Quite a complex little beast, but certainly you know, it's well laid out in terms of what it's, you know, it's sort of real belt and braces kind of power supply engineering there. We can see there's our AC/DC Akadaka switch on the back there. There's our front panel power button, which then goes through a flexible shaft there right through to the selection switch on the back there. Very, very nice. And but yeah, this is an example of unfortunately, you know, the power supply was fine, it was working fine, then all of a sudden, bang, well, no bang, our LED just went out and we get no power to anything. So we may now be turning this into a power supply troubleshooting issue. Maybe the fault on the boards that caused the power supply fault, which we don't actually know what was wrong with the power supply, maybe it's taken out the power supply again because it's been powered up for too long or something. I don't know. Anyway, Murphy gets you every time. You can see small attention to details like the temperature sensor down on that heatsink there. So they've got some over temp protection on that switching transistor there with that relatively small internal heatsink. Very nice. I can't find any internal fuses in this. Doesn't look obvious. I don't have a schematic of this, by the way. And by the way, the service manual for this DSA does not include the schematics. It's got extensive troubleshooting and a block diagram and everything else, but doesn't have the schematics of the main unit, let alone this third-party power supply. So I don't know. Something's gone. It certainly wasn't giving 5 volts out. Whether or not it needs something, you know, something to read back or something like that in order to power up the supply and generate the 5 volts. It might have an automatic cutout or something like that. I don't know. But nothing obviously blowing here. I can't smell anything. Can't see anything. So I was hoping not to do a power supply troubleshooting. I like a good digital board level troubleshooting. That's what I was hoping for, and it was looking that way, but bugger. And regardless of what we switch on there, we've got some decaying voltages on some of these output heat sinks here, and so it looks like we're just getting nothing on the input, presumably. Like, I can't get in there and probe the caps and stuff like that because I'd have to get to the underside of the board under there. By the way, extremely very high voltages inside here. You don't want to be dicking around with power supplies, switch mode power supplies, unless you know what you're doing. But Yeah, we just got basic decaying voltage on the secondary side there, which indicates that there's absolutely nothing happening on the primary to drive that secondary. So something has gone kaput on the primary side, but thankfully we have that DC input here. Maybe I can try that and see what happens. Maybe it's the AC part. I don't know. And there you go, you betcha. Green light back on, and we're drawing almost an amp at 12 volts with no load on here at all. So anyway, we're back in business. So I don't know, I'll troubleshoot that mains thing later. I'll just power this thing from 12 volts and continue troubleshooting. Oh, by the way, this input accepts anywhere from 12 to 28 volts DC, so pretty decent range. And we are back in business. External 12 volt DC power at about 5 amps. That gives us about 60 odd watts power consumption for this thing. And that 2-pin LEMO connector in there, I'm not sure exactly the type, but the contacts in there precisely, or seem to precisely take a standard 2mm test probe pin. So, hey, hacked up some old probes and we're good to go. There are actually some test points on the back of these. They're single inline headers here, and although they're not marked on the silk screen on the bottom, because there is no silk on the bottom, which is really rather annoying, you can get the reference from the service manual. So 1, 2, 3, 4, 5, pin 5 there, that is the main CPU reset line. As you can see, it's high, and which it should be, of course, and I can push the reset button on the back here and I can watch that go low. So that's all working fine, but I cannot get any of the clocks on this thing at all. So there's several clock points on this thing and I cannot get any of them. So that is the first port of call. And next step apparently is to test the I2C bus. I'm not sure what it's actually connected to or what it's testing, but pins 1 and 2 of this single inline header here as we actually power the thing up, and it's supposed to give a couple of bursts upon power up, and of course, you know, it doesn't. It gives zip. Where the 70 or 80 page troubleshooting guide stops, because it says, well, if you don't get those clocks and if you don't get the I2C bursts at power up there, then this A7 board, it's called, this is A6, this is the A7 board, the main processor board is faulty, in quote marks. So yeah, well, obviously part of that clock circuit up there, it looks like a discrete transistor job. So yeah, it'd be handy if I had the schematic, but yeah, it's still doable. And we've got ourselves a little socketed E² prom there, and that's obviously the I2C bus device that those 2 pins I was probing before. It's got to talk to that E² prom on power up, so it might be interesting to actually have a read of that. But anyway, that is not going to happen unless you've got a main clock, and there's our main clock circuit here with our I just tweaked this little trimmer here just to see if it did anything. You know, it may have, you know, I don't know, sure doubt had some sort of gunk in it, or who knows. But I was just playing around with that, and because we can always trim it later, and no, it makes no difference. So it looks like we've got a that's a 39.645 megahertz, I think, something like that, 845 megahertz crystal, and we're getting no oscillation around that at all. That little thingy down there is a 79L12 negative 12 volt voltage regulator, I believe. But once again, it's hard to probe this stuff because this board, to work, gets all its power from the main motherboard connector here, which, to put it in, you've got to put it in upside down, of course, unless you want to take out the motherboard connector and the power supply, and it gets all real nasty. So rather difficult to probe, and you'll notice that there's no silkscreen designators on the top here at all, which makes it a bit harder. But of course the service manual has overlays and stuff like that telling you where the various test points and things to measure are. But that's where I've gotten to at this stage. No clocks anywhere on this thing. Got to be something to do with that discrete transistor oscillator down there. I can't see anything else. I mean, you know, there's another crystal over here, 24 megahertz, but that's for the floppy controller here. So it looks like everything is derived, as far as the processor goes, from this main crystal down here. Check out what I just sort of found sort of hanging in there and just sort of pulled that out. Obviously, there's a nice little LEMO connector there. That's probably going through maybe to the microphone. Yeah, that'd be the microphone connector on the front panel. I love these little LEMO connectors. Very nice, but man, they're expensive. And this crystal oscillator circuit here, totally weird. I don't know what's going on at all. We've got the almost 40 megahertz crystal here, but it's in parallel with a very low value 1.5 ohm resistor, and I've never seen, well, can't say I've ever seen that configuration before. And it's between, it looks like it's between basically via the series cap there and via the series trim cap here, between the emitter of two transistors. I've checked those out. They appear to be NPN transistors, and well, I don't know. I haven't reverse engineered the whole thing, but it just looks really strange, and I'm not sure what the hell's going on there at all. I mean, if it was a Colpitts configuration, you know, we'd expect to see one end of the crystal going down to ground, or one end of the series cap going down to ground, or something like that, but that doesn't seem to be the case. So it's likely a variation of the Pierce configuration, but I don't know. I don't like it at all. I got no idea what's going on here, and I cannot find a schematic for this thing at all. Hopeless. It's not in the service manual. Service manual's got lots of great top-level overlay stuff and signal names and stuff like that, and test points, but doesn't have the schematic. So I'm left wondering if there is actually a fault in this thing. I mean, I could probably get, I'm not going to get the exact 39.845 megahertz or whatever it is, but maybe I could whack in just a, you know, any old crystal I've got. Maybe I've got a 40 megahertz one lying around or something, and see if the oscillator at least starts up, because that crystal could be physically damaged perhaps, something like that, or that there's some other control signal shutting down, or some other thing shutting down the oscillator and not allowing it to start up. So, you know, the fault could be elsewhere and the oscillator could be a red herring. But usually, you know, you don't you don't shut down the main oscillator on a product like this. It just doesn't really happen. It's just usually free running. You power it up, it's free running, and Bob's your uncle. And what do you know, an old video card came in handy. 40 megahertz. That'll do. We'll give that a whirl. Well, that was a long shot and it didn't work out. So it's exactly the same as before. So I put the old crystal back in, and we'll have to start probing around further. I don't know. Like the power good, the power supply has a couple of signals coming out of it. There's a power good signal from it, and that's all okay. And you know, I'm sort of running through the test points in the service manual, and they all seem okay, except for the fact that there's no clock there. Well, when in doubt, measure voltages. I've had to get in there. I've soldered a couple of pins onto that 79L12 voltage regulator on the back. So let's have a look. That's the input. Not minus 19.2. Okay, I think this uses plus minus 18 volt rails, but you know, okay, it's there. And the output, minus 1.85 volts. Something's wrong there. So either that regulator's gone bung, or something is dragging it down. And we'll just measure the resistance of the output rail of that. No, 6.8k. Of course, the figure's meaningless. You're just looking for a low, you know, a low impedance path there to load that thing down. But no, that's no problem whatsoever. So it's not like the output of that regulator, at least, you know, just at sort of the low voltage from the multimeter is not loaded down. So possibly we might have a dud voltage regulator there. Now, of course, there's a couple of ways you can attack this. One is to try and remove a component or cut a trace or something to disable the output of that, i.e. remove the load, and see if the voltages actually comes good, and then you can isolate it either to the regulator or to the load itself, or you can lift the pin maybe if you're really careful, something like that. I don't think I have any surface mount negative 12 volt regs there in stock, and of course it looks like it is powering some part of this oscillator circuit, because sort of this, if they've got like the ground plane cut out the bottom, this whole section here is this oscillator. So no wonder the damn thing's not starting up if we're not getting that negative 12 volt rail there. And of course, if they had easily accessible test points on the bottom of this thing labeled, like they don't even have silkscreen on this board, but you don't need silkscreen if you're trying to save some dollars. Not sure why you would in a $20,000 instrument like this. It makes no sense. I'm not sure why they left the silkscreen off at all. But anyway, you could have at least etched them into the copper on the back or something. Plenty of room, very sparse layout, plenty of room for labeled test points. So no excuse. Poor design. And by the way, if you have a look at the traces on this thing is completely looks like completely auto routed, really. It's just, right angle traces everywhere. A human hasn't really had much input into this sucker at all. You can see the various layers, one going one direction, the other layers going the other direction, and just, no real after tidy up done essentially. So yeah, not nice. And I bodged in a crappy old TO2207912 package, probably 25 years old, 30 years old from my junk bin, but it works. I measured it and we're getting negative 12 volts out, so that regulator was faulty. We're drawing more current now. It was drawing just under 4 amps before, now it's drawing 4.9 because the damn thing is now, ta-da! You bloody beauty! Look at that! What a winner! Okay, let's power it on again. I've got the screen and the keyboard plugged back in, so it should draw even more power. There's some status LEDs on the back here, which were given an error code that are in the manual, so, but that could be anything. Let's power it up. Oh, look! Bloody ripper! Look at this! There it is! Oh, what a Bobby Dazzler! Booting system! It's working! Woohoo! I'm not going to say that's all. Oh, hardware error. Oh, see, fault logs. Yeah, okay, so yeah. That was a fault log. The LEDs are flashing. The half LEDs were flashing down here. Calibration in progress. Oh, bloody beauty. It's looking like it's working all right. The screen works, that's for sure. That dodgy cover on it, going to have to take that off. And hardware error, see fault log, but calibration failure, change state of autocal, remove this message, blah, 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 blah. But at least we've got the thing to boot. So there you go. It was that 79, negative 12 volt 79L12 voltage regulator. Of course, I'm going to have to get proper SO8 package 1 and stick it back in there. Don't want to keep my bodge TO220 in there. That's no good, but that, folks, is fantastic. And I go from excitement over that win to the BNC input connectors. I just noticed they're a little bit crusty in there, not the best. I mean, they're still usable, of course, but maybe, if you were restoring this thing, you might want to go in there and possibly replace them with some brand spanking new ones. They've had a bit of wear. And there's our fault log. I2C, no device acknowledged. Occurred at 6126. No idea what that means, but yeah, we can follow the extensive troubleshooting in the manual and track this down bit by bit. Calibration failure, yeah, don't know what's going on there, but hey, it seems to be, generically booting up and working. We're getting a fault code on the LEDs on the back. We need to check that out and cross-reference the table in the manual, but this thing is, well, at least we're at a point where we can actually, use the thing and start troubleshooting. Well, I'd better not get too excited because the quick self-confidence test failed. Now I've gone into some more specific tests here. I did the ADC gate array test. It's failed. Display, well, display's obviously working. Let's try the digital processor. Let's try all of the digital processor. Pass, pass, pass. Of course, the digital processor is going to work, otherwise we probably wouldn't get to this point. So that's all sweet. But yeah, ADC gate array doesn't sound good. Inputs, I don't know, let's test them all. On the channel 1, yeah, disconnect, yeah. Offset fails, yeah, we've got various fails, and you should have seen the list of, yeah, not good. I mean, the guy said, he sold it to me, said that, yeah, it was working before the power supply failed, but, you know, who knows what the power supply is taken out, so, oh, could be a long road ahead, but anyway, the quick confidence test, I mean, that's just many pages of fail on the quick confidence, let alone the long confidence test. Check that out. Boom. Nah. Well, I've got a machine that boots, but doesn't do much else, I'm afraid. Well, we at least got to this point. Better than nothing, I guess. And hey, we at least got something that we could actually repair and get working again, at least to a basic level. This could be beyond economical repair. I don't know. There's a lot more steps I'm gonna have to go through to test individual modules. Can't possibly do it today. Not a chance. So we're gonna have to leave that for future videos, but I hope you like that. We did find the problem. Probably could have found it a lot quicker if they had the marked test points on the top there, you know, accessible test points and marked, because, you know, the golden rule of troubleshooting, thou shalt test voltages. And sure, if they had those test points there, I would have tested them straight away, and I wouldn't have suspected the crystal or something else in the circuit or something, you know, reset lines and all sorts of, you know, things like that, checking out all that sort of stuff, and would have found that much quicker. But hey, you know, it didn't take that long in the end, and I found it, and it's at least back up and running, so we have a baseline to work from. Error codes, red LEDs flashing in the back, and I've plugged in the rear panel. That wasn't the I2C issue and things like that, so I don't know. Anyway, if you want to discuss it, jump on over to the EEVblog forum. Hope you liked it. Catch you next time.